Somewhere in the universe, there are objects so dense, so extreme, that the laws of physics almost break around them. They don't shine like normal stars. Yet scientists consider them among the most dangerous objects in existence. If one of them passed near Earth, it could wipe out life without ever touching our planet. These objects are called neutron stars. Let me give you one fact before we continue. A neutron star can be smaller than a city, but heavier than our sun. A single teaspoon of its material would weigh around 1 billion tons on Earth. That's heavier than mountains, heavier than aircraft carriers, heavier than anything you can imagine holding. So the question is, how can something so small become so unbelievably massive? Not all stars die the same way. When most stars die, they fade away quietly. Some become white dwarfs. Some simply cool down and disappear. But very large stars die violently. Stars that are 8 to 20 times more massive than our sun don't go gently. They explode. And when they explode, they don't just end their lives. They create something new. Birth through destruction. Supernova. Inside every massive star, nuclear fusion keeps gravity under control. Hydrogen becomes helium. Helium becomes heavier elements. But eventually, the star creates iron. And iron is special. Iron produces no energy. The moment iron takes over, gravity wins. The star collapses in less than a second, then explodes in a supernova brighter than entire galaxies. What's left behind is the crushed heart of the star. Matter under extreme pressure. During the collapse, something extraordinary happens. Gravity becomes so intense that atoms are destroyed. Electrons are forced into protons, and when that happens, neutrons are born. The star is no longer made of atoms. It becomes a gigantic ball of pure neutrons. This is a neutron star, only 20 kilometers wide, yet holding more mass than the sun. At this point, matter behaves in ways we still don't fully understand. The discovery that shocked scientists. In 1967, astronomers detected perfectly repeating radio signals from space. The signals were so precise that scientists briefly believed they were artificial, alien signals. They even named them LGM, Little Green Men. But the truth was stranger. The signals came from neutron stars spinning hundreds of times per second. These were the first pulsars ever discovered. Neutron stars are not all the same. Over time, scientists realized neutron stars come in different forms. Some spin rapidly, sending radio beams like cosmic lighthouses. Some become magnetars, with magnetic fields trillions of times stronger than Earth's. These stars can tear atoms apart from thousands of kilometers away. Others spin so fast they rotate 700 times every second, making them the fastest known objects in the universe, each type more extreme than the last. When neutron stars collide. Now imagine this. Two neutron stars trapped by gravity, spiraling toward each other for millions of years. As they collide, they release more energy than our sun will produce in its entire lifetime. Space itself ripples. Gold, platinum, and heavy elements are created. And sometimes, the collision gives birth to a black hole. These are among the most powerful events ever observed in the universe. Why they matter. Neutron stars are not science fiction. They exist. They spin. They collide. They challenge everything we know about matter, gravity, and reality. Small in size, but terrifying in power. And they remind us that the universe is not only beautiful, it is dangerous. If you want a full video about what would happen if a neutron star passed near Earth, tell me in the comments.